from page 6 onwards, we are going to deal with word problem revolving around equation of a circle. Now, let us take a look at question 3. In part 1, you are supposed to find the equation of a circle where the radius as well as the center are given. So very quickly, let us apply what we have learned. Let us use the information to put it in standard form. After that, we will have to do the necessary expansion before changing it to general form. The idea of changing to a general form is to equate to 0. So our part 1 is done. Now, let us take a look at part 2. Now that we have found the equation of the circle, in part 2, they told us this circle actually passes through this point 5, k. This means to say that 5, k actually lies on the circumference of the circle. Using your concept where you learn a point lying on a straight line means you can substitute the point on the straight line. The same concept applies here. If this point lies on the circumference of the circle, we can substitute this particular point into the equation of the circle, which is what I'm going to do right now. Substitute it into the equation of the circle. Notice that this is a quadratic equation in terms of k. We are supposed to find this equation and solve for it. We will need to make use of the quadratic formula. Notice we are dealing with surd and we will need to find the value of k in exact form. In order for it to satisfy the condition that k must be greater than 0, we can only accept one answer. And that will be my final answer since k is greater than 0. Now, let us move to part 3. Looking at your own question, notice part 3 is a very interesting question. They would like us to determine if the point -3, 8 lies inside or outside the circle, and we will need to show our working clearly. Before I get started, let me give you a simple analogy. If I have a circle given to me, if I need to know whether a particular point actually lies inside or outside the circle, let me use another point A. If point A lies inside the circle, the distance from A to the center of the circle must obviously be smaller than or shorter than the radius of the circle. If I have another point B, if it's lying outside the circle, it is very obvious that the distance between the center of the circle to B must be longer or greater than the radius of the circle. Using this simple concept, that's how I'm going to tackle part 3. I'm going to find the distance between the point that is given to the center, to the circle. So using the distance formula, I'm going to calculate this distance and check whether is it shorter or longer than the radius of the circle. So after I've done my necessary working, notice that the distance between the 2 points is 8.602. This is clearly less than the radius of 10. So our conclusion is very obvious. This particular point, negative 3,8, will lie inside the circle. With that, you will be able to find the following question very similar to the one that I've just tackled. I would like to leave it to you to try it.